Good morning. My name is Talib Mohammed. My workmate Ahmed Adil and Ali Abdullah. We uh, we proposed this case study modeling and evaluation of the Zigbee based on smart farm for Dr. Gan. We start by outlines. We start by outlines. We start by introduction. We will define here wireless network and explain the Zigbee architecture and literature review. Then the methodology. In the methodology, we will talk about the scenarios we created and the simulation, and then the result and the conclusion. Introduction. Wireless sensor network is a wireless network consisting of especially distribution separate device using a sensor to monitoring physical condition. Working process of the sensor network. We have three parts. First part using it here to send using it to send the information of the value from the sensor through it. And then the second one is the protocols using to communicate this information. And finally, we have the external um, system using to monitoring or observe these information coming from the sensor. This figure shows some application uh, of the wireless sensor like water quality, quality of the shipment condition, smartphone, smart farm, fire detector, uh, uh, electronics levels and traffic configurations and there is a lot of things, smart parking and smart streets, smart city, smart roads and smart lights, etc. Zigbee system architecture. We can define Zigbee is the mesh network technology. Zigbee system architecture is we can see here we have the MAC and we have the physical layers. These behaviors is covered by IEEE 802.15.4. Then we have the collection of the layers. For example, Zigbee 2007 specification. This specification is covered the Zigbee and the Zigbee Pro. In the top, we have the application profiles. These home automation and the building automation and smart energy. This is an example on applications. Literature review. In this section in this part of case study, we summarize some of our previous work that have a connection or similar to our work, but we find some advantages. This is the advantages from our point and the disadvantage at same. And start to find a new work in 2015 and 2014. Methodology in this part, like I said above, is we're talking about the simulation. In this case study, we use QualNet 5.2 to simulate and create the 5 scenarios by using these parameters in the table to show us. We use a different number of nodes and we use a CBR as a data traffic. And the most important is the routing protocol. It's using AOD routing protocol. It's a proactive routing protocol, and it is sometimes it's called on-demand routing protocol. They call it on this on-demand because because it's created just when needed. These the 5 scenarios we created: 20 node and 4 CBR, three, by the way, 3 static and 1 mobile, and then we increase the number of nodes. Then in scenario 2 and scenario 4, and then scenario 4 it's 30 number of nodes, but we increase the CBR. That's traffic. CBR, by the way, CBR is the we have 8 CBR. We use 3 as a static and 5 as the mobile nodes. And in the scenario 5, we use 30 nodes and 8 CPR, but 7 statics and 1 mobile sensor. Here show us scenario 1. We have only 1 connection. This is the mobile. It looks like a car in the simulation platform. And here is scenario 2. Take this picture, this screenshot during the running. This scenario 3 and 4. Then the last one is 5. Results. At the beginning of the results, we have we use a 3-part matrix of parameters to explain the results. First one is the throughput. We try to define the throughput. Throughput is the average rate of the successfully data packets received at the destination. From observe this chart, show the throughput increase with the number of the nodes. This is also a result of the increased node density in the smart farm, and it's also observed based on the sensor on scenario 4 and 5 addition of CBR application from mobile source, an increase in the throughput by the higher value. Increasing the CBR from the static node also increase the throughput with lazy value that in mobile nodes. End-to-end delay. Average end-to-end delay. This matrix or this parameter is calculated by subtracting time at which first packet was transmitted by the source and which packet is received by the destination. And observe or monitoring and observe in this chart. Here we have scenario number 1 and number 3 that average jitter end-to-end increase a deployed node are increase in the farm, and it's seen the addition of the CBR from mobile node sensor mobile node in scenario 4, increasing the average end-to-end delay is the highest value. Then is the highest value. For the addition of the CBR from the static node, as in scenario number 5, there's also increase the average end-to-end, but is very small than by 0.1 seconds. Average jitter. Average jitter is the value of the variation and the arrive the time of the packet at the destination. And observe here and in this chart, scenario number 1, 2, and 3, the average jitter increasing as the number of the nodes increase, but the difference of the increase is very little in the 30 and 40 node scenario number 2 and 3, compared to the 30 and 20 node scenario number 2 and 1. The result of the average jitter in scenario number 4 and 5 is similar than the result in average end-to-end delay. For the addition of this of end-to-end delay of the CBR mobile nodes in scenario number 4. Increase the average jitter by the highest value in average jitter, and like we see here, and it's end-to-end delay, so it's the highest is the highest value. For the addition of the static nodes in scenario number 5, there's also an increase, but it's very small, then is by 0.2 seconds. Conclusion: this simulation results show us an increase in throughput, average end-to-end delay, average jitter, as a number of nodes increasing. The increasing of the CBR source show in a regular pattern of the result pattern. The throughput increase almost by the same amount on the both static and mobile. All other metrics, average jitter and end-to-end delay and throughput, when the CPR is increasing from mobile node than from the static node. And thank you. And for any question or explain, please email me. This is my email. And thank you so much.